Hello everyone, this is Mohan Vansal, going to present a research paper on title Analysis and Forecasting of the COVID-19 Epidemic Curve in 14th International Conference on Information Technology and Electrical Engineering, and this work is done in the collaboration with Pratik Jain, Sumit Mohanty and Anju Das in India. This is the outline of my presentation, in which first I will discuss about the introduction of this work, then we will talk about proposed methodology for analysis and forecasting of the COVID data. Later on, we will talk about the results and discussion, and we will show the analysis of the forecasting of the data, and thereafter we will conclude our presentation by showing some differences. So, in the introduction, let me see how COVID-19 affect throughout the world, affect whole the world. So, the coronavirus disease 2019 is widely popular as COVID-19, which has emerged as a supreme challenge for the whole world as well as India. And as of now, approximately 6.5, even more than 6.5 million people died in the world, which is a large population of the world. The major setback to the world was in 2021 as a result of the second and third wave of COVID-19 in all the countries of the world. The government and healthcare sectors were not aware of the subsequent possible waves due to the lack of data analysis and improper forecasting model. So, therefore, the proper analysis of the available data, proper analysis of the historical data and finding the inflection point of the epidemic curve is very necessary to predict the future cases or forecast the future cases to prepare the government and health sector for mitigating the effect of upcoming waves of COVID-19. Therefore, our aim of doing this work is to do some analysis and the forecast the future cases, so government and health sector can be aware about upcoming waves and cases. So, now we are going to see how we have done this work, what is the proposed methodology for analysis and forecasting of the data for epidemic curve. So, in this work, first the number of COVID cases and mortality cases are plotted to analyze the historical data. Later, a second derivative plot are computed to find the local maxima and minima so that the inflection point can be found. This is the simplest method. The second derivative method is the simplest method, which helps in tracking new waves and variants of the data for epidemic curve. Further, these epidemic curves of India are compared with the data of UK and US, and the autoregressive integrated moving average model, that is known as ARIMA model, are used on the data, existing data, for the forecasting the future predictions. Finally, the number of future cases for India is predicted by using ARIMA model, and it is compared with the actual data. And here we can observe this graph. The left one is the incidences or confirmed cases for UK, US and India, and right graph is representing to the mortality cases of UK, US and India. The blue graph in both the plots are representing the data of India. Red graphs are representing for the data of US, and black graphs are representing the data for UK. And here we can observe during the second wave, this is the first wave and this is the second wave. During the second wave of the India, it was highly infected. It was highly infected and no one was aware about such kind of the incidents during that time. And it can be observed from this plot that in a single day we got more than 3.5 lakhs people were infected in a single day, and mortality was 4,000 per day. Thereafter we can see the confirmed cases, total confirmed cases of US is very high. It's approximately 3.5 crore in mid of 2021 and more than 3 crore for India at the time. And if we talk about the mortality rate, total cases of US was approximately 6 lakh and more than 6 lakhs, and total cases of mortality in India was more than 4 lakh, and UK was a small country, therefore cases was approximately more than 1 lakh for UK. in 2021. So this is the just analysis and understanding of the data, how much people was infected, how much mortality rate, what was the mortality rate in different 3 countries. Thereafter, we have seen, we will do the analysis to find the inflection point, and we use the second derivative method to find the inflection point. Second derivative is nothing but the derivative, double derivative of the data. So if FT is considered as the data of confirmed cases that is collected from Johns Hopkins University, which consists of several data sets, the inflection point at a point can be calculated by f double dash t, it representing double derivative of the data of confirmed cases. If it is 0 at certain point at time t naught is equal to 0, then we can say that inflection point at a t is equal to t naught. So if double derivative of function is 0 at t naught, therefore the inflection point occurs at point t is equal to t naught. So it can be computed by taking the double derivative. So first derivative dt is ft plus delta t minus ft divided by delta t, and second derivative can be found by taking the derivative of the first derivative, where delta t we use as 30 days of the interval to find the differences in current sample and the 30-day samples. Now, this is the plot of the second derivative in all 3 countries. Blue one is again representing to the India, red one is representing to the US, and black one is representing to the UK. And here this is the concave down curve and this is the concave up curve. When data is changing, and this is double derivative plot, if f double dash t, this plot is f double dash t is 0. So we can see that this is the inflection point. These are the inflection points. Okay, so here in India, this is the one inflection point, this is the one inflection point, and so on. So inflection point states that it shows that curve is changing from negative to positive or positive to negative. And if we compare the mortality rate and confirmed cases in India, so it can be observed the blue curve is death case and red curve is the confirmed case. So here we can see in the beginning India was less affected, but after July 2020 India was started affecting, and it was till November and December till end of the 2020, and it started again infecting in mid of the May, and curve is sharply increased. Curve is sharply increased. It means previously cases was coming very less, then suddenly cases increased too much in mid of 2021, and both are proportional to each other. So therefore, if cases are increasing, deaths are also increasing. So, so to overcome this situation, prediction and forecasting is very important. So now we will see what kind of the predictions we can do and what are the methodology we have used for the forecasting. So this is a proposed framework for ARIMA modeling for forecasting of the COVID data. So the time series data is available as like this is the time series data, daily incidence data we have, how many confirmed cases, how many death cases. Thereafter, we will apply this time series data to check the stationarity. So how we will check? We will use the augmented Dickey Fuller test, that is also called as ADF test. If ADF test is passed to check the similarity, to check the stationarity, we will apply the ARIMA model, and if ADF test is failed in the stationarity, we will take the derivative or difference of the series to find out the to convert the series in the stationarity. If series is non-stationary or data is non-stationary, we will apply the differencing, then data may convert to the stationarity. Thereafter, we will apply the modeling of the ACF and PACF functions to check the ARIMA model order. After getting the ARIMA model order, we will feed these parameters in the ARIMA model, and we will predict the data or will forecast the data. So this is a simple framework of the ARIMA model that we will see what is the ADF test and how it helps in the stationarity. So as I already told you, the augmented Dickey Fuller test is used to assess the time series stationarity, and there are 2 parameters to check the null hypothesis of this test. First one is the ADF test statistics. It should be the negative, and second one is the p-value of the data, p value that should be minimum or it should be less than some threshold value, and usually threshold value is 0.05. If ADF test statistic is negative and p value is less than 0.05, we can say that the data series or time series is stationary. But if value is higher, like ADF test statistic is positive and p value is greater than 0.05, then it will be considered as it is non-stationary series. So we tested on the confirmed cases, and we checked that ADF test statistics is 1.4657, which is the positive data, and p value is 0.997. Therefore, it is non-stationary. This time series is non-stationary. So to convert the time series from non-stationary to stationary, we will apply some differencing. Then one differencing is applied. First order differencing is applied. After applying the first order differencing, we got the ADF test statistic and p value as given minus 3.424 and 0.010 respectively, and these two parameters are satisfying the property of the stationarity, and the series will be considered as the stationary. So now we got one parameter for the ARIMA model, which is D, which is equal to 1. Now we will have to calculate the model orders like P and Q. P are the model order of AR, autoregressive, and Q is the model order for moving average. So we use the AIC and BIC, these are the two criteria to select the model order for forecasting for ARIMA model. So AIC is the archaic information criteria and BIC is the Bayesian information criteria. These are the two important parameters or two important criteria for selecting model order. So how we can use this AIC and BIC for computation of time series? So it is basically based on the likelihood function. So here this is the information criteria, which is mk minus 2l, l is the log likelihood, k is the value which is 2 for AIC, and it is log n for BIC, where n is the number of samples in the series, and m is the total number of parameters, which is equal to p plus q plus d plus 1, where d is the number of differencing, which is 1 we are considering here, because in the one differencing or first order differencing time series is stationary. P and Q are the parameters or model orders, and lower AIC and BIC value will give us the best model order. So now we will see the table for AIC. Here these are the AIC value for different model order, AR model order and different MA model order. So P is the AR order and Q is the MA order. So at different value of P and Q, for D is equal to 1, we are getting this table, and we can observe we got minimum value as 11,471 when P is equal to 3 and Q is equal to 2, or P is equal to 3 and Q is equal to 3. Now we check with the BIC, that is the Bayesian information criteria. In the similar way, we got BIC when P is 3 and Q is 2, which is minimum value, and approximate to that we got another value which is at P is equal to 3 and Q is equal to 3, 11,506. So now we can observe best model order should be 3 and 2, but for the better understanding we tested with P is equal to 3, Q is equal to 2 and P is equal to 3 and Q is equal to 3, and results are given here for ARIMA model. So here this is the ARIMA for 313 where P is 3, D is 1, Q is 3, and ARIMA 312 where P is 3, Q is 1, sorry D is 1, Q is 2. So here these are the minimum value of AIC and BIC, and P value should be less than 0.05, but here moving average 3, which is not significant because P value is higher than the threshold. So these AR1, AR2, AR3 are the autoregressive model autoregressive parameters, and MA1, MA2, MA3 are the moving average parameters, and these are the coefficient value at different value of P. So here this MA3 is not relevant for the ARIMA model fitting, therefore we can ignore it, and we are getting the best results with 312 because BIC is also minimum, AIC is also minimum in case of 312, and this is the P value which is 000 here. Now we will see the forecasting results. In the forecasting results, we can observe red graph is showing that confirmed cases, that the historical data, and this zone is the predictions of forecasting. So here blue curve is representing the forecasted, that means this curve goes like this, and the shaded region is representing the 95% confidence interval. It means it has a confidence of 95% that data will lie in this region after getting the actual data. So this is the prediction or forecasting by the ARIMA model for COVID-19 positive cases, and here this is the actual cases after getting the results, after getting the genuine data. We have plotted it, and we can see that this data is also plotting in the range, in this similar range. After July, we can observe this is lying inside the confidence interval range. So therefore our prediction is quite good for analysis of the forecasting and for the forecasting of the COVID-19 data with the help of ARIMA model. And this is the complete conclusion and summary of this talk. This study shows the importance of finding inflection point interval and prediction the inflection point. This inflection point of the epidemic curve of US-UK interprets that these countries have passed through more than 3 different waves of COVID-19 in mid-2021. India has also gone through deadliest second wave as per the calculation of the inflection point. This calculation was done at the time of second wave and increased severity of it in mid-2021. The forecasting of future epidemic curve in terms of infected cases are also done in this work. It was observed from figure that number of cases was increasing consistently based on the forecasting of the time series data, as we saw in the last slide. Number of cases was increased consistently based on the forecasting of the data. The forecasting recommended government, the forecasting can recommend the government for accelerating the vaccination process and increasing the manpower in terms of the health workers, and it can arrange some kind of the beds in the hospital, ICU rooms, and oxygen as per the requirement for the based on the forecasting and predictions for prior in prior. And these are all references for this work. We have used the methodology, and thank you so much for listening this session.